So in the last class we talked about text blob library, right? So today what we are going to do is, now we have completed about the NLTK library, we have talked about text blob library, and now we'll be talking about the final library, which is the SpaCy library. Alright, so there are other libraries, okay? I'm not saying this is the only libraries. You also have Stanford NLP library and a lot more. If you go and search, you'll see a lot of libraries with different tasks, different variations, and basically whenever you're doing a task, you have to see which one fits best for your requirements, for your situation, for your task and everything. All right, but we are only going to focus on these three libraries, right? And then what will happen is, we'll go about and talk about some other different stuff. Okay, we'll discuss that later on, but now, for now, let us understand about this SpaCy library. So SpaCy is an open source library, and the best thing about SpaCy is basically it is open source, obviously free, and it is on natural language processing. Okay, and so let us first start. So here you can read about a lot of things about SpaCy. I'm not going to go over all of this, but what you can see here is basically SpaCy is compatible with Python. Python is basically Python version of which uses C. Alright, so here what we're going to do is, we're going to understand about this whole SpaCy library. So let us first start by installing SpaCy. So if you are doing your SpaCy installation in your Jupyter notebook, use this statement. Okay, use either this or this statement, any one. If you want to install it using a Conda version, in that case go for this. Alright, I am going to do this in my base version itself. Okay, I am not going to open another Conda library, or I'm not going to create another environment just for an installation. Okay, so I'm just gonna skip these two, and the reason why I'm skipping this install is because it is already installed in my system. If you want, you can check this out in this manner. So let's add this. So this takes some time obviously to start and everything. I just loaded the thing, but you can see here requirements are already satisfied. You can see most of my requirements are satisfied. If you'll see the whole thing, you'll realize that SpaCy is already installed in my local system. Alright, so next what we will do is, basically we'll understand about some of the things. So like other libraries like text blob, like NLTK, this also has a few functionalities. So you have identifying of tokens. You will have NER. NER is named entity recognition, if you remember. So named entity recognition. So what this does is, basically if you talk about named entity recognition, this is basically useful if you want to do task like understanding whether this is a name of a person or an organization or a place. So whatever be the thing, this can be used for named entity recognition. So you can see here the installation has been completed, but since it was already installed, so it said that requirements already satisfied, right? So the whole thing has been done. The next thing what I'm going to do is basically import SpaCy, and then I'm going to load a library from this. Okay, so let us do that. And once that has been done, see, whenever you are putting anything, you have to use this NLP thing. Okay, so like if you remember in text blob also, in text blob you had text blob as a kind of variable or as a kind of string or some kind of representation like that, right? In this way also you'll have to have NLP. So whenever you have a string, you have to wrap it up in this NLP thing, and then you have to save it in a variable. Then for every token you'll have to print out all of these things. So here what we are going to print out is basically token.text. So we'll see all the tokens that have been created. We'll see token.pos. POS, if you remember, is paths of speech. So it will tell me all the paths of speech, that is. Okay, and then you have token.dep. So dep basically means it shows you the dependency. So there are some, I am not very familiar with the whole grammar part or anything, but a few things that I can say about this is, basically, let's say you have a sentence, right? So in a sentence, some words are dependent on the other words. So this basically depth shows the how dependent, or how are they dependent on each other, right? So now you can see this whole thing has been done. Apple is looking at buying UK startup for 1 billion US dollars. Okay, so here you can see the different tokens are Apple is looking at buying UK startup for dollars is different, one is different, and billion is different, right? Then this is followed by parts of speech. So you have this basically stands for proper noun, auxiliary, I think this is for verb, this is for adjective, I don't know. So there are different things. Obviously you will have to go into the SpaCy library and then you can see what these short forms stand for, all right? So that you can do. And this finally, this dependency basically says, okay, this is the subject, this is the root of the sentence, this is the composite part of the sentence, and different things, right? So I am not very familiar, like I said, very familiar with all these grammar words, so I might not be the best person to understand or explain to you about the different meanings and different grammatical relations that they have with each other. But yeah, I can say this much, that this is the whole thing about it. Okay, so we got parts of speech and we got the dependencies, right, from the token.txt. Next what we are going to do is we are just going to tokenize it, just basic tokenization. Okay, so now here you can see it has been tokenized, and one thing that you must see here is, see, the dollar is different, the one is different, and the billion is different. Even though dollar one is together, it has been split into two different parts, two different tokens, right? This is one thing that you should notice. See here it shows you how it has been split. Okay, and the one thing also that is the thing about SpaCy is basically SpaCy, it can also identify your prefixes and your postfixes. Okay, so it knows the prefix and postfix of a particular word and it can work according to that, right? So you can see here you have a prefix, you have a suffix, exception, and so on. So this is what this goes about and tells you about the whole thing. If there is a problem, I would say read the whole thing entirely. It's not that difficult. If you read it, you'll be able to understand, all right? And basically those who work with this natural language processing, they are very familiar with all of this, because these are some of the stuff that is required for your pre-processing of the data, all right? Then you have parts of speech and the dependency part. If you remember, we already talked about this here, right? If you remember, for every text we got the part of speech and we got the dependency of it. But here also let us see this all over again. Okay, so let us run this. So the outputs that you will be getting here will be basically text, your the lemmatization of this thing, the POS as in parts of speech of this thing, the tag and depth, then you have the shape, is alpha, and is stop. Okay, so we are going to understand each and everything. Let us look here. So you have first the token.txt, which is coronavirus. Okay, then you have the lemmatization. So lemmatization basically means, if you remember, each word there is a starting word or a basic word from which the word has originated, right? So lemmatization, what it does is basically it changes your particular word into the actual word from which it has been originated. So if you have a word is, it changes to be, because be is the origin word and is, was, were, all of this has come from be word, all right? So that is the lemmatization here. So you get the lemmatization, then you get the part of speech. So it is a proper noun. Okay, you get the tag and you get the depth. This basically depth means basically the dependency, and you have the shape, then you have is alpha, and then is stop, all right? So this is the whole thing. So here is alpha means, is this a part of an, so here alpha means, is this an alpha character or not? Okay, and is stop means basically, is this a part of your stop word or not? Alright, so that is what this whole thing is. So you will get all these outputs and then you can see, okay, is this a part of the stop word? No. If it is not a part of the stop word, you can add it to your tokens. If it is, then just discard the word. So in that way, basically all the pre-processing can be done using this. Alright. Next, the other thing that is good about the SpaCy is basically, see, SpaCy, what it does is it also has a DisplayCy, which is a visualizer. So visualization is very helpful here. So what this will do is basically give you a very good idea about how it looks like in visual space. So how words are interconnected with each other, how they are related to each other, what is the dependency and everything. So like you can see here, this is how they are dependent on each other, they are related to each other, right? So you can see all of these things. And also, in fact, you can also also gives you a server running here, so you can check this out even if you want to check it out in a different tab. All right, so that is one thing. You can stop this. So this is a very good thing about SpaCy, which you do not find in other text pre-processing libraries. That is that SpaCy helps in basically giving you a very good display of what is the whole point. Okay, so the next thing that we are going to see about SpaCy is the named entity recognition. So if you remember, we have already talked about named entity recognitions, right? So here also we are going to understand this whole thing. So first you have this wrapped around this NLP token, and then you go and loop over this whole thing. So you get the text, you get the start char, you get the end char, and then you finally get the label. Okay, so let us talk about what each of this is basically. Okay, so if you see, so it starts with text. So the text is 31 here in this case. Okay, and then so this is basically just looping over all the entities. All right, so here we are going to run this on all the entities. Okay, so that means whatever is an entity here will be used, and we will only get the outputs using that. Okay, so other words are not going to be used here. So means, what is an entity? Basically anything that is a person, a country, a product, a book title, or something like that, that will be basically looped. The rest will not be looped. So out of all these, the entities are basically 31 and India here. Okay, so once you have that, the first thing it gives you is a start character. So after counting all of this, where does this start? So it starts here, this is your 66th character, it ends at your 68th character. Alright, then you have, for India it is the same thing, the start character and the end character, and finally you have the label. So label is basically what entity is it about. Okay, what entity are we talking about? It gives you that. Again, these are small words. If you are interested, you can go into the SpaCy library, which is here, and you can read about all of this. Okay, what it includes, what it does not include, what it means. So here you can see it has GPE here written, right, for India. So GPE basically means geopolitical entity. That means it's a country, city, states, or anything of that sort. Okay, next you have visualizing the named entity recognizer. So like you were visualizing earlier about the dependencies and tags, so here we are going to visualize the named entity recognizer. So if we run this, again this will also give you an entire server where you can see this. So it points out these two different your named entities. So 31 is basically a cardinal value, and India is basically a geopolitical entity. Alright, and if you go in here, you can see it also displays it in a different tab. It opens a server where you can load the whole thing, right? Other than that, okay, so these are some of the things that are very different in SpaCy. You will not find it in different libraries like NLTK or TextBlob. Other than that, the other thing that you can use it basically is to find the word vectors and the similarity. Now how the word vectors are found out and used, we'll talk about this later on. But what I can say basically is, see, let's suppose you have two words. You have, let's say, a word king, and then you have a word man. So you know how these two words are related, right? You know they are kind of similar. They both represent a male person. So in that way you can say, okay, they two are somehow related. In the same way you can say a woman and a queen is related, right? So these are different. These things are used and they are found out using your word vectors and just finding out the similarities between it. Okay, so here what we are going to do is basically we are going to understand the similarities between some different words. So here we have some different words and we're going to understand about it. So again you have to put this inside the NLP wrapper, and then once that has been done, you can find out the answers. So here for every token you are first writing the token text. That means it will be lion, bear, apple, banana, and whatever this is. Okay, then it has a vector. So is there a vector for this word in the SpaCy library? Okay, so it will either give a true or false. So if the word is there in the library, that means it's a true, otherwise it's a false. Now out of all these three words are words that can appear in the library because they appear in English dictionary, right? This is just a made up word, hence you will find it as a false, and the rest all are true. So it does not have a vector because it does not exist in the SpaCy library, because this is not a word. Okay, so then you have vector norm. So vector norm basically means is it finds the L2 norm of the token's vector. we'll talk about all this later on. Okay, I'll promise you I'll explain all of this in details. Then you have token dot is oov means out of library. So all these first are not out of library, but the last one, since this is not a word, it is out of your library. Okay, the next thing that we are going to do is basically we are going to find the similarities between each and every word here. Okay, so you're going to find a similarity between lion and lion, lion and bear, lion and cow, lion apple, lion mango, lion spinach. In the same way, bear and lion, bear and bear, and so on. Okay, you get the idea, I'm pretty sure. So this is basically what we were talking about, word vectors and similarity. Now how these vectors come out, how we find the similarities, we'll talk about this. But for now, let us understand the library here. So let us run this. So here you can see lion and lion, there has a similarity of 1. 1 is the highest, that means it is highly similar. Okay, lion and bear, you have a similarity of 0.6. Okay, because they both are wild animals, they both eat flesh and everything. So whatever be the similarities, but they are similar 0.6%. Okay, sorry, 0.6 probability is that they are similar. Then you have lion and cow, it is 0.47. I think that is because they both are animals. Then you have lion and apple. So lion and apple are very less related. Lion and mango, even less related. Lion and spinach, even less related. Then you have bear and lion. So this number is exactly equal to this number, if you can see. So in this same way, so in this way, what they have done is basically they have related each and every token here to the every other token, and this has been done using this dot similarity function. Okay, so this is present in your SpaCy library. And after this has been done, I would suggest you to go through the pipeline. So pipeline basically shows you, it gives you a hint or an idea of how this is happening. Okay, so you have the text, you pass it through a tokenizer, then you pass it through a tagger, a parser, and NER, and this is the whole part until you get the final doc. So the final doc is the one which can be used for the preparation of this whole thing. Okay, so when you see here in the doc and everything, here doc, so what this basically means is here this thing, so it goes through a lot of stuff until you get the final value. So it starts with tokenizer, where your text is converted into tokens. If you remember, tokens are basically, you have words. So you have, suppose I am a person, and then the tokens will be I am a and person, right? So this is your first part, that is your tokenizer. Next thing what will happen is it will pass through a tagger. So tagger, what it will give you, it will give you parts of speech tags. Okay, so that has been done. Then it is passed through a parser. Parser basically assigns you dependency libraries. So dependency labels is basically like, is this a subject, is this something else, is this a conjunction, I don't know, whatever the different dependency libraries are, it assigns you those libraries. Next, once that has been done, it passes through a named entity recognition. So India and other countries will be assigned that GPE tag, that is the geopolitical entities, and so on. Okay, next, once that has been done, named entity recognition, then you have text.cat, text cat. Okay, so that means a text categorizer, what it will do is it will assign document labels, and then finally you will have the whole thing. So this is the pipeline of a SpaCy library. So this is a whole thing about SpaCy. There are a few good things about the library, like I was saying. First of all, what is different is it has a visualization option. You can visualize the whole thing. Okay, then again, other than that, you have named entities, and you have all these visual formats which make it like very easy for everyone to understand, even though you might not be from here. Okay, so you might not be into this whole NLP thing, but even then it makes it very easy to understand. Then the other thing is basically it has a similarity function, so we can use it for a lot of ways. Okay, so this uses something known as word-to-vec algorithm. We will talk about this also one by one, just give some time. And then finally we talked about the whole pipeline. So I hope you liked this video, I hope you understood it. If not, go into the SpaCy library, the whole documentation itself, any place where you have to start, wherever you have to learn anything, I always suggest to go through the actual documentation, because they have written the whole thing, so they know how this has been done. So it is very good to understand it from their point of view. Okay, and I hope you enjoyed the video and keep learning.